All right, let's jump right in. Every single day, you use apps that hold some of your most sensitive information. But have you ever really stopped to think about what's standing between that data and a potential attacker? Well, today, we're going to pull back the curtain on the WAF, or Web Application Firewall. It's the unsung hero of application security.
Think about it. The apps we use for banking, for shopping, for everything, are just sitting out there on the internet. And that makes them a prime target. They are constantly being poked and prodded for weaknesses by attackers who are trying to find a way in to get their hands on all that valuable data.
Now, take a look at this little bit of code. This is a classic, and it is a devastatingly effective attack. An attacker can just sneak this into a search box or a login form. The real trick, the poison, is that last part, OR1 equals 1. I mean, 1 always equals 1, right? So that statement is always true. It tricks the database into completely ignoring the user ID check and just dumping everything, all its user data. It's simple, it's elegant, and it is incredibly dangerous.
And SQL injection? That's just the tip of the iceberg. Attackers have a whole arsenal of tricks, like cross-site scripting or XSS to inject nasty scripts into websites, or massive DDoS attacks to just overwhelm an app and knock it offline. The key thing to understand is that these attacks aren't just banging on the network door. They are aimed squarely at the logic of the application itself.
So, how in the world do you stop a threat that's woven into what looks like perfectly normal traffic from a user? You need more than just a bouncer at the front door. You need a security guard that actually understands the language being spoken inside the building.
To really get this, we have to take a quick peek at the rulebook for how computers talk to each other. It's called the OSI model. It basically breaks down all of network communication into 7 distinct layers. Now don't worry, we don't need a deep dive on all 7, but the difference between a couple of them is absolutely crucial here.
And this right here, this is the whole game. A traditional network firewall is like that bouncer at the front door. It checks addresses, things like IPs and ports, to see who's allowed in. It's working at the network level. But a WAF? A WAF operates way up at layer 7, the application layer. It's more like an agent inside the club listening to the actual conversations to understand the content of what's being said.
So here's the bottom line. A network firewall knows who is connecting, but it has absolutely no idea what they're actually saying. A WAF, because it's right there listening to the conversation, can inspect the real content of the HTTP requests. It can spot that malicious SQL code we saw earlier and block it before it ever reaches the application.
So how does a WAF actually decide what's good and what's bad? Let's take a look at how it thinks. It's not magic, you know. It's actually a pretty clever combination of different security models.
At its heart, WAF uses one of 2 basic approaches. The first is a negative security model, or deny listing. Think of this like having a blacklist of known troublemakers. It blocks any request that matches a known attack pattern. The other way is a positive model, or allow listing, which is way stricter. That's like having an exclusive, invitation-only guest list. If a request doesn't perfectly match a pre-approved, known safe format, it's not getting in, period.
Okay, but that brings up a really important question. What happens when an attacker comes up with a totally brand new type of attack that isn't on any blacklist yet? These are the zero-day attacks, and this is where those older, just rule-based WAFs could sometimes fall short, and it's why the technology had to get a lot smarter.
And this is where modern WAFs get really intelligent. They bring in artificial intelligence and machine learning. So instead of just relying on a list of what's bad, they spend time building a detailed profile of what's normal for your specific application. Then, when a request comes in that deviates from that normal baseline, the WAF flags it as an anomaly. And that is how you can catch a zero-day attack before anyone even knows it exists.
And this is what it looks like from the defender's side of the screen. A good WAF dashboard takes all that complex behind-the-scenes work and turns it into clear, visual intelligence. You can see where attacks are coming from, what kind they are, and exactly how the WAF is stopping them, all as it happens.
Okay, so you're sold. You need a WAF. But how do you actually get one up and running? Well, there are a few different ways to deploy them, and each one has its own set of pros and cons. The 2 most common options are cloud and on-premise. A cloud WAF is basically a service you subscribe to. It's super fast to set up, scales automatically, and the provider handles all the messy updates. An on-premise WAF, on the other hand, is either a piece of hardware or a virtual machine that lives in your own data center. This gives you total, granular control, but it also means a bigger upfront cost, and you need a skilled team to manage it.
But it doesn't have to be an either-or choice. A lot of larger companies use a hybrid strategy. They'll use the speed and scale of a cloud WAF for all their public-facing websites, while keeping a tightly controlled on-premise WAF to guard their most critical internal systems. Best of both worlds.
So WAF is a seriously powerful tool, but it's important to remember it doesn't work in a vacuum. It's a key player on a much larger team of security defenses, so let's get clear on exactly where it fits in the lineup.
You're going to hear a whole alphabet soup of acronyms thrown around. The big three you'll run into are WAF, which we now know, IPS, which is an intrusion prevention system, and NGFW, the next generation firewall. They all sound kind of similar, but trust me, they have very different jobs. Think of it like this. A next-generation firewall is like a general practitioner. It provides a really broad range of network security, mixing a traditional firewall with an IPS. It's essential, for sure, but it's not a deep expert in any one thing. A WAF, however, is a specialist. It's like a neurosurgeon, but for your web applications. It provides incredibly deep inspection and protection, but it focuses only on web traffic. So, the takeaway here is crucial. You absolutely need both. They work together to create what we call a layered defense. Your network firewall protects the perimeter, the outer walls, and the WAF protects the application at the very core. One does not replace the other.
But of course, the story doesn't end there. Technology never stands still. As our applications have gotten way more complex and spread out, the WAF has had to evolve right along with them. And this is such a critical insight. The old security model was built for castles, single monolithic applications with a clear moat around them. But modern applications? They aren't castles. They're these interconnected webs of tiny services talking to each other through APIs, hosted all over the cloud and being updated constantly. This explosion in complexity just shatters that old model, and it demands a much more integrated way of thinking about security.
And that brings us to the next evolution, WAF, which stands for Web Application and API Protection. This is the next step. It takes that core intelligence of a WAF and bundles it together with other absolutely essential services into a single cohesive cloud-delivered platform.
A real WAF platform is built for this new interconnected world. Of course, it includes an advanced WAF, but it also has dedicated API security to protect those crucial data connections, really sophisticated bot protection to stop all the automated attacks, and massive scale DDoS protection. It's the whole security suite for a modern app. So from a humble rule-based firewall to these integrated AI-driven WAP platforms, application security is in this constant arms race against attackers. It really leaves us with a final thought to chew on. As our reliance on these complex apps grows every single day, as we build our businesses and our lives on them, how do we make sure the defenses protecting them are always one step ahead?